It's Sunday, September 8th, and we're tracking several disturbances in the Atlantic this week. We have one in the Gulf of Mexico, which is now being dubbed Potential Tropical Cyclone 6 by the Hurricane Center. We'll talk about this one pretty much throughout the entire video. I do want to mention that we've got a couple other disturbances to watch. Way out in the tropical Atlantic, we've got one disturbance way out here in the central tropical Atlantic, which has a high chance of developing as we go throughout the next several days. And this will be tracking generally towards the west and may approach the Leeward Islands as we go into latter portions of the week. But environmental conditions are forecast to get a bit worse for the system as it gets there. So as of right now, no big threat from this system. We'll also have another system behind it, but that system is forecast to stay out to sea, and at this time is no threat to land, so not really worth mentioning that. I will show you the tropical weather outlook, though, so you can see the probabilities. You can see that both of these have pretty good odds of becoming systems. The leading one is 70%, the one trailing 50%, and our system in the Gulf of Mexico would still be at 90% because it's not yet a tropical cyclone. It's, again, a potential tropical cyclone. We're going to switch over to that one now as we just got the designation from the Hurricane Center. And if you're still unfamiliar with this classification, a potential tropical cyclone is a system that's likely to bring impacts of tropical storm or hurricane force to areas along the coastline in the next 2 days, but it's not yet meeting the criteria to be designated as a tropical cyclone. It's pretty much a way for the Hurricane Center to designate a system and get hurricane and tropical storm watches and warnings ahead of time, even if a system is not developed into a storm. Helps with public messaging in that way. Now, right now, the system is not well developed at all, as you can tell on satellite imagery. That's why it's not being classified as a tropical cyclone. If we look at the visible satellite imagery, we see a very broad, low system here. And there's also 2 vorticity maximums here. You can see one on the northern part of this map with that strong northerly flow coming out of northeastern Mexico, and we've got southeasterly flow on the east side. That's one of the vorticity maximums that we have. We also have another one down here. It's kind of hard to pick this one out on satellite, but if we look at recon data, we can see that there is one here. There's a little bit of a wind shift once this plane had gone through this part of the storm. So we have another vorticity maximum here. Now what's going to happen over the next couple of days is these 2 vorticity maximums are going to be revolving around each other. It's a little bit like a Fujiwara effect, to where this one's going to be rotating down, this one's going to be rotating up. And eventually these are going to merge together. And once we have that, we're likely to see something more coherent form out of that. And models are very keen on this happening. In fact, that's why we have the 90% chance of development from the Hurricane Center. Now, this will be a bit of a sensitive type of developments. This is a bit of more of an odd development overall for a tropical cyclone, not your traditional one. And there are some issues the system could face as it moves north. Now, right now, a bunch of models are showing that the system could intensify as it comes north. The model consensus has the system perhaps closing in on hurricane intensity when it comes ashore. Right now, somewhere in Texas or Louisiana is the current forecast. But there are some things we need to first iron out before we can fully see what the system is going to do, if it's going to fully take advantage of its environment. One thing is, with this development, we have 2 vorticity maximums. One idea that some models have tried to show is that one of these vorticity maximums, like I think the European a few days ago have shown this vorticity maximum being a little bit stronger, and it keeps this vorticity strung out quite a bit. Now, on those runs, this was going into Mexico, so it really didn't develop in time on those model runs. But now that we have the system offshore, it's likely still to form, even if, say, this low is a little bit stronger. In fact, it looks like it's stronger now than this other vorticity maximum. But if it does keep it strung out a little bit longer, it could hold the system back with intensifying. There also may be a slight issue of shear. There is some shear impacting the system. If we look at the upper level winds off the H-Wharf, you can see that it's on the southern periphery of an upper level high. So this is bringing a little bit of northeasterly shear aloft, and this is pushing some of that convection off towards the south and east. And what the H-Warp shows is that as the system develops, so by this time our vorticity maximums are merging together, but we see that the mid-level center is pushed way off towards the west over Mexico. And this is a very decoupled system, not vertically stacked in any way. And because of this, the system struggles quite a bit on the H4. It never really gets itself vertically stacked. As once we get towards the coast, now shear will decrease once it starts moving north. You can see it's in this very favorable upper level pattern. But if it cannot rebound itself, if it cannot get those centers vertically stacked, once it starts to move north, we're going to start getting a little bit more shear from this approaching trough in the southwest US. And this is going to be bringing increased shear to our storm. You can see on the H4 that now the shear vector has switched. Now the mid-level center is more north and northwest of the storm rather than being west. And because that shear continues to increase, we really don't see the system intensifying too much on the model. Compare this to the half-say model. This model shows the system getting vertically stacked under the lighter shear environment, and because it's able to do that, it's able to stay more vertically stacked as the shear increases towards landfall, and we get intensification of this system right about towards landfall. Then it starts to get more sheared as the shear gets too overwhelming for the storm. And these are really the two scenarios that we have for this storm. It could either do any of these. It could struggle and barely remain a tropical storm as it comes ashore, or we could be looking at an intensifying hurricane as it comes in. You can see that shear as well on the half-A as it comes towards the coast. Now, one thing you'll also be able to pick out with this upper level wind plus, we have this area of increased winds taking place over Texas and Oklahoma. This is a jet streak. And as this system comes up, it will be in a somewhat optimal position for a jet interaction to occur with the storm. And in extreme cases, this could allow the system to, in a way, fend off the shear a bit better all the way to landfall. The GFS has been showing this a little bit more. You can see that it shows the system similar to the halves, being more vertically stacked. And with that jet interaction, it intensifies it quite significantly. In fact, it gets it down to 957 millibars. Now, I think the GFS is going a little bit too strong here. Is this possible? Certainly, we've certainly seen this happen before in jet interactions, but there's a lot that has to go right for this type of a scenario to happen. And right now, something like the GFS is showing, which just could be a Category 3 hurricane on the model, that's very unlikely at this time. We're much more likely to see a stronger tropical storm, maybe a low-end hurricane come in here to the coastline. Now, this system, you can see, is forecast to come into Louisiana on a lot of these forecast tracks. It's going to be turning towards the northeast, sort of parallel to the Texas coast. There is a little bit of wiggle room. Could it make landfall in Texas? That's still possible. Could it make landfall in southeastern Louisiana? That's a bit possible because of this approach angle with this trough. But if it does have a little bit more time over water, it's kind of finicky here because of the shear increasing. But if it's in just the right area, it could allow additional intensification. Now, if it comes into southeastern Louisiana, then I think we could see the system stop intensifying before landfall, because the shear will probably get a little bit too much for that. And if we're further west, we may limit intensification because of limited ocean time. Now, the Hurricane Center has looked at all this data, and they've issued their forecast, which is right here. You can see that they're expecting the system to reach hurricane intensity as we go through the middle part of the week, as it comes up towards the Texas coast or southwestern Louisiana. This is generally in the model consensus right now of all the scenarios. Now, like I said, there's some variability here. Could it stay very weak? Absolutely. Could it be a little bit stronger than this at landfall? Absolutely. There's some things that we still need to iron out because we don't have, even a well-formed low-pressure area at this time. It's not a tropical cyclone yet. Once we get it here, say east of Mexico, then a lot of questions will be answered. If it's actually getting itself vertically stacked and more well-developed here east of Mexico, then I'd say we could be seeing a stronger system come in here to southwestern Louisiana and southeastern Texas. But as of right now, expect a hurricane as we go into the middle part of the week. And regardless, tropical storm or hurricane, we're going to be expecting a lot of heavy rainfall here, and we could have additional flooding onto what we've already had. We've had just a draped frontal boundary over the past several days in this region, so we've already gotten a lot of rainfall here, and you don't need much to cause much more flooding issues, and this could absolutely worsen those impacts, especially across Louisiana. Now, keep in mind as well, with that jet interaction and that westerly shear, all the thunderstorms are really going to be pushed off towards the eastern side. So even if the system is coming into, say, southeastern Texas or southwestern Louisiana, we could still be looking at rainfall here in southeastern Louisiana. In fact, we might have a rainfall forecast from the Weather Prediction Center. In fact, I don't think we do yet. Products are just now loading in. In fact, there it is. You can see from the Weather Prediction Center forecasting, looks like widespread over southwestern and south central Louisiana, 6 to 8 inches of rain across a broader area from, say, the central Texas coast all the way to the Florida panhandle even. We're expecting 4 to 6 inches. And this will also spread inland as the system is forecast to move further north. You can see on this forecast cone, moving generally on this forecast up the Mississippi River Valley, and we could be looking at some impacts here as well over the southern U.S. and getting into the Ohio Valley as the system moves north. And could we potentially have some tornadoes there as well? It's possible, especially on that northeastern quadrant, and that will always be a concern with tropical systems as they come in here. That's all that I've got for today. Again, we're watching several areas in the Atlantic. Just as a review, we've got PTC 6 here in the Gulf of Mexico, and we've also got these two other systems way out here in the tropical Atlantic. No threat as of right now to land from these. If there is more threat from these eventually, we'll talk about them as needed. But that's all for now. Thanks for watching.